Hello everyone, welcome back to the channel Mining Engineering. I am Satyavrata. In today's video, we'll discuss what is a shovel or excavator, and we will discuss some numerical problems related to this topic. So, shovel or excavator. Excavators are heavy construction equipment consisting of a boom, dipper, bucket, and gap on a rotating platform known as the house. In general, the excavators are called as shovel. This is one shovel, and this shovel is a crawler mounted shovel. You can see this is a crawler or the chain on which this shovel arrangement is there. This is the house of that shovel where the engine part is situated, and above the engine there is the operator cabin. The back part is called the counterweight of the shovel because it will counterbalance the weight of the material which will be taken on this bucket. This is the dipper. This is a dipper handle. This is the boom of that shovel, and this is the hoisting rope. This is a rope shovel because all the bucket movement, bucket opening, bucket closing is controlled by this rope. So this is called a rope shovel. Shovels are mounted on crawler arrangement and thus pose poor mobility because this is a chain mounted or the crawler mounted shovel. So it will go on a very less speed. Like the tire mounted vehicle can move from one place to another place at a very high speed. For example, in the case of HEMM, heavy earth moving machineries, the tire mounted vehicle can move from one place to another place, for example, at a speed of 30 km per hour or 20 km per hour. But in the case of this crawler mounted HEMM, heavy earth moving machineries, it can move only 1 to 2 km in 1 hour. Due to crawler-mounted arrangement, these machines pose high digging capacity as compared to a tire-mounted machines. This is one advantage of the crawler-mounted arrangement. Because of this crawler-mounted, here on the surface of the earth and this crawler, there will be high friction, so there will be high amount of digging capacity while it will be implemented on a face. Types of mining shovel. Shovel can be classified as of three types. On the type of operation, we can say one is dipper shovel, another one is a stripper shovel, and the third one is the backhoe. Dipper shovel is the normal shovel which we normally found in our day-to-day mining operation. For example, while loading the dumper, stripper shovels are similar kind to the drag line. These are used for side casting of the material from one place to another place. And backhoe you normally found in the coal mining. Here in the case of backhoe, the digging style is from the top to bottom, while in the deeper shovel, the digging style is from the bottom to top. Further, as per the power delivery, you can say the excavator or the shovels are of two types, like the mechanical or the rope shovel or the hydraulic shovel. In the rope shovel, the the bucket movement or the bucket opening, closing, all things are managed by the rope, and the rope are controlled by the mechanical motor. In the case of hydraulic shovel, hydraulic cylinders are used, and by pumping the hydraulic fluid, the bucket opening, bucket closing, bucket movement, all these operations are managed here. And further, the shovels are classified as electric shovel or diesel shovel as per the fuel which is used in the shovel. If we are using electrical supply for the energy, which required to the shovel, that's called the electrical shovel. And while we are using diesel for that energy requirement, then the shovels are called the diesel shovel. Now let us discuss the dipper shovel. Dipper shovel essentially comprises of a bucket open in the front side. Thus this bucket discharges through opening a door placed behind the mouth. Dipper shovel are of two types, like rope dipper shovel, hydraulic dipper shovel. Here the boom, the bucket movement occurs from bottom to top, as I have already told you. So this is one hydraulic dipper shovel. So why it is hydraulic? Because this bucket movement is controlled by this hydraulic cylinder. These are the hydraulic cylinders you can see. And these hydraulic cylinders, pumps are used for pumping this hydraulic fluid, which will create the hydraulic pressure, and it will help in the movement of the bucket. And in the case of the dipper shovel, the bucket movement will be from the bottom towards the top, and it will dig from the bottom towards the top, and it will discharge the material through this point. This plate will open, and the metal will be discharged through this opening. This is one rope dipper shovel. You can see these are the rope which controls the bucket movement, and the motors are used for controlling the rope. So bucket opening, closing, boom movement, all the functions are managed through the motor connected with the rope. Now let's come to the stripping shovel. Stripping shovel essentially has a long boom to dump the material at a long distance. It is similar to a drag line. It is basically of rope type because the boom length is very high, so it will be difficult to control it by the hydraulic cylinder. Here the boom with the bucket movement occurs from bottom towards the top. Now come to the backhoe. Backhoe is applicable where the excavator is allowed to work from a higher elevation to dig at below floor level. Bucket movement is from the top towards the bottom. Poor digging efficiency as compared to the dipper. Mostly hydraulic. You can see this is the hydraulic backhoe. It is essentially used in a blasted rock material. So why it is hydraulic? Because it is controlled by the hydraulic cylinder. Okay. This is the backhoe. You can see the bucket position. Here the bucket, here the backhoe will dig the material from up towards the bottom. Now let's calculate the performance of a shovel. Production calculation. We'll calculate the production of the shovel in ton per hour. So for calculation of the production, we need to know what is the bucket capacity of that shovel. Let us suppose the bucket capacity is BC in meter cube. Now the fill factor is F, density of that material, the material which we are handling. Let us suppose we are handling iron ore. So the density will be 2.5 ton per meter cube. That means if we take 1 meter cube of material, the weight will be 2.5 ton. If we are handling coal, in that case it will be 1.2 ton per meter cube. That means if we take 1 meter cube of coal, then the weight will be 1.2 ton. Now the cycle time of a shovel for one bucket filling, that means for one bucket filling, how much time it will take, that is called the T. So these are our parameters: bucket capacity, fill factor, density, and the cycle time. Now the question is, determine the capacity of a shovel if the capacity of the bucket is 4.5 meter cube. Average time cycle is found to be 30 seconds. The bucket fill factor is 0.8 and the bulk density of the material is 1.5. Determine the hourly capacity of the shovel effective loading hour utilization is 50%. So this is a question. So here it is given the bucket capacity is 4.5 meter cube. So this is our bucket capacity and the fill factor is 0.8, that means 80%. That means when you take the material through the bucket will not take total 4.5 meter cube quantity material. You're getting the point. Let us suppose you have this bucket or this packet. This packet you can say it as a bucket. Its capacity is 4.5. Let us suppose 4.5 meter cube, and we have put this finger chips. Let us suppose they are the iron ore material inside that bucket. So we can say that the bucket is not completely full because there are a lot of gaps inside the bucket. You cannot say it is a completely filled up by the material. There are various gaps. That means we can say it is 80% full by the material. It's not a completely 100% fill. It's a 80% fill up by the material. So that is called the fill factor. So if you are handling iron ore, if you are handling coal or any other material, while you take that material, it will not completely fill up the bucket capacity. There will be some fill factor. It will fill 80% or 70% or 60%. So here in the question, it is given that the fill factor is 0.8. It will take 80% of 4.5 meter cube material. That means 4.5 into 0.8. That means 3.6 meter cube. So the bucket capacity is 4.5 meter cube. However, the materials which are inside the bucket, that will be 3.6 meter cube because there is a gap. There are a lot of gaps. Now let's convert volume to tonnage. We have densities given. Now we have calculated that there are 3.6 meter cube of material inside the bucket and the density of the material is given. Density of the material is 1.5, that is ton per meter cube. So while multiplying 3.6 meter cube into 1.5 ton per meter cube, it will give 5.4 ton. That means the bucket is carrying 5.4 ton of material. Now again, the shovel can load 5.4 ton of material per load. So per load it can take 5.4 ton of material. Or per load time taken is 30 seconds. It is given the average time cycle is found to be 30 seconds. So per load time taken is 30 seconds. We need to find out per hour production. So in 30 seconds, material production is 5.4 ton. It's given. Now in 1 hour, that is in 3600 second, 1 hour you can convert it to second, that is 3600 second. So in 30 second the metal production is 5.4. So in 1 hour, that is 3600 second, the metal production will be 648 ton per hour. Again in that question it is given that effective loading hour utilization is 50%. That means we are not utilizing the shovel completely 100%. That means the shovel is not utilized total time, that is 1 hour. There is a break of 50%. That means the shovel operator or the machine breakdown. There is a from 1 hour there is 30% breakdown. Utilization hour is 50%. That means we are just utilizing half time from that 1 hour time. That means 30 minutes we are wasting. So hourly production will be 648 ton per hour into 0.5 because we are utilizing only half time. So the hourly production will be 324 ton per hour. We'll discuss more problem in the part 2.
It's yours.